Hello students, today we are starting a new chapter and it is chapter 5 heat and we will be doing part 1. The first topic of discussion is the heat flow. If we take a cup of hot tea and we touch it, let us say we are touching this hot cup of tea. Okay. When you touch this hot cup of tea, we will feel hot. And if you take an ice cube, how will you feel? If you touch an ice cube, you will feel cold. You will get the sensation of cold. Now, the reason why this is happening is because there is a flow of heat. There is a transfer of heat and that is why you feel hot. If you lose heat, you will feel cold. Now, when you touch a cup of hot tea, the heat gets transferred to you, so you will feel hot. If you touch a piece of ice, the heat will get transferred to the ice cube and you will feel cold because you are losing heat. The reason why this is happening is because, as you know, the normal body temperature of a human body is 37 degrees centigrade, and normally a cup of hot tea will be at about 60 degrees centigrade. As the temperature of the cup of hot tea is more than the temperature of our body, the heat will flow from the hot body to the cold body. Heat will always flow from a body which is hot to a body that is cold, and because heat is flowing from the hot cup to the human body, to your body, you will feel hot. In the case of ice, as you know, the temperature of ice is 0 degrees centigrade, and as you can see, your body is hotter than an ice. So, the direction of heat flow will be from your body to the ice, and since you are losing heat, you will feel cold. Now, supposing if you have an object, let us say if you have an object which is at 37 degrees centigrade, when you touch this object, how will you feel? You will feel neither hot neither cold, because your body temperature and that object is at the same temperature. So, you will neither lose heat or neither gain heat. So, this object, when you touch it, it will feel neither hot neither cold. So, once again, if you touch a hot object, you will feel hot because the hot object is at a higher temperature than yours. So, heat will flow into you, so you will feel hot. If you touch a cold object whose temperature is lower than you, heat will flow from your body to the cold object and you will feel cold. If you touch a body which is at the same temperature, you will neither feel hot nor feel cold, because there is no transfer of heat from your body, or neither will the heat get transferred from the body to you. Next, let us discuss the units of heat. Heat is measured in number 1, a unit called joule, and number B, a unit called calorie. So, these are the two units in which heat is measured. Now, calorie is defined as calorie is defined as the amount of heat required to raise the temperature of 1 gram of water through 1 degree centigrade. That means, if you have a vessel, okay, in which there is 1 gram of water and you provide heat to it, and let us say the temperature of water, you put a thermometer, let us say the temperature of water is at 37 degrees centigrade, all right, and you heat it and you raise the temperature to 38 degrees centigrade, which will give you a difference of 1 degree centigrade. So, you have provided 1 calorie of heat to raise the temperature of 1 gram of water by 1 degree centigrade. So, once again, if you take 1 gram of water and heat from, let us say, 37 to 38, it could be any other temperature, let us say from 1 to 2 degrees also, as long as the jump of temperature is 1 degree, you would have provided a heat quantity of 1 calorie. Now, calorie is a small unit. So, the bigger unit of calorie is kilocalorie, and calorie is related to kilocalorie in the following manner: 1 kilocalorie. Calorie is equivalent to 1000 calorie. This is something that you have to remember and note down. And 1 calorie is related to joule also in the following manner: 1 calorie is 4.168 joules. So, this is how calorie is related to joule. So, please remember, 1 kilocalorie is equal to 1000 calories and 1 calorie is equal to 1.168 joules, and in one decimal place you can write it down as 4.2 joules to make it easy to calculate. Next, we are discussing about the various sources of heat. The main sources of heat are: number A, it is the sun; number B, it is fire; and number C, it is electricity. So, in this case, the sun directly provides heat, fire also directly provides heat, electricity does not provide heat directly, but through devices, and you would need to connect an electricity to a device. It could be an electric cooker or an electric heater. So, any device that converts electricity to heat will basically give you heat in this case, and electricity is not providing heat directly, unlike the sun and fire. So, these are the main sources: the sun, fire and electricity will convert can be converted into heat through various devices, and I have given 2 examples here: electric cooker and electric heater. Next, we are discussing about inflammable and non-flammable substances. And non-flammable Now, inflammable substances are substances that easily catch fire. So, easily catches fire. Now, examples of substances that easily catch fire, as you know, is dry paper. It can be dry wood. So, these are different solids that can catch fire. Let us say liquids, for example, petrol, which is a liquid which can catch fire, and let us say LPG, which is a liquefied petroleum gas which can catch fire, and also, for example, hydrogen, which is a gas, and this can easily catch fire. Hydrogen HYDROG, hydrogen gas, and these can catch fire. So these are different solids. Dry paper and dry wood are solids which can easily catch fire. Petrol can easily catch fire, and LPG and hydrogen gas which can easily catch fire. So these are inflammable substances, and these inflammable substances, they and they combine oxygen to produce a lot of heat. It can produce a lot of heat, and along with it, it can also produce light, but here we are mainly concerned with heat. So once again, inflammable substances are substances that can easily catch fire. These are a few examples of substances that can catch fire easily, as you must have observed as a phenomena. And inflammable substances, they combine with oxygen, and it can produce a lot of heat and light also. Now coming to non-flammable substances, obviously are substances that do not catch fire easily, 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 and examples are let's say metals which do not catch fire easily, and let's say stone which do not catch fire, and let's say brick, and let's say water, and let's say as a gas, let's say carbon dioxide, sorry. So these are substances that don't catch fire easily. Now fire is very important to us, because using fire we can cook, it helps give us light, it helps give us heat. So fire is very, very useful, but then again, fire, if you don't use it carefully, it is very dangerous. So you do need to keep the fire safety in mind, and some of the precautions that you need to take are the following. So as you know, fire, it generates a lot of heat. And because it generates a lot of heat, it can be injurious. That means fire can burn your skin, it can cause damage to your skin, it can cause damage to you, and so it's dangerous. It can be damaging, it can damage property, it can burn houses, it can burn down cars, it can burn down forests, so it's damaging. And obviously, because it's damaging, it is also destructive. So fire, if you don't control it properly, it can cause a lot of problems. It can be injurious, it can be damaging, it can be destructive. So what are the precautions that you should take to make sure that fire doesn't get out of control and can be used safely? So first of all, inflammable substance. Inflammable substance must not be kept near fire, obviously, like supposing paper. For example, if you have a burning candle and you have got a stack of papers, that's the worst combination to keep, because supposing the candle falls down on the paper will catch fire, and that fire can spread through other items which is also around it. Supposing if a gas is leaking in your kitchen, you should not put on an electrical switch, because the electrical switch, when you switch it on, it creates a spark, and that spark would be enough to ignite the gas that is in the kitchen. So you need to be careful. So in this case, in your kitchen, LPG gas pipes must be regularly inspected, okay, to make sure that there is no leaks. If you smell gas, the first thing that you should do is always open the windows, make sure, first of all, close the regulator, open the windows, let the gas out, and do not switch on the electricity, and do not switch on the electrical switch, because that can create a spark and that can create fire. Next, let us discuss about temperature and its measurement. First of all, let us define temperature. Temperature is defined as the degree of hotness or coldness. So, temperature defined as degree of hotness and coldness, and the units that we use to measure temperature are two of them. The first one is degree Celsius, and the other unit is degree Fahrenheit. And we have one more unit for measurement of temperature, and that is the SI unit of temperature, and that SI unit of temperature is Kelvin, Kelvin. So we have three units that is used to measure temperature, and the device used to measure temperature is called a thermometer. Thermo means heat and meter means a device for measuring. So, temperature and its measurement. Temperature is defined as the degree of hotness or coldness. The different units that we use for measure temperature is degree Celsius and degree Fahrenheit. The SI unit of measurement of temperature is Kelvin, and the device that we used to measure temperature is called a thermometer. Now, next let us discuss about the device that is used to measure temperature and how it is constructed. So, as you already know, just we discussed that the device that is used to measure temperature is called a thermometer. So, we will discuss on how a thermometer is constructed. A thermometer is basically made of glass, and it is made of a glass bulb, and this end of the bulb is basically extended into a stem, and in which there is a tiny capillary tube, and in this tube, in this bulb, a liquid metal called mercury is put, and at the beginning this is blank, so we need to calibrate that. So, what we do is we take a funnel, and in the funnel we put ice cubes, and we stick the thermometer in, and as you know, the mercury is a liquid metal and it expands on heating and contracts on cooling. So, as the mercury expands on heating, the mercury level will rise up the capillary tube, and as the mercury cools down, the mercury level will fall down, come down, and it will give an indication of the reading. So, this is called the stem. This tube inside is called the capillary tube, and this portion is called the bulb, which holds the mercury. So, when you put it in ice, the mercury level will come down to a certain level, and that level we mark it as 0 degree centigrade, and this 0 degree centigrade is called the lower fixed point, okay, which is the melting point of ice. Thereafter, we take a vessel in which there is water and we boil it, we provide heat, and in this we stick the thermometer in and expose it to the steam. So, the temperature will rise up to a certain level, okay, and that we mark it as 100 degrees centigrade, which is called upper fixed point, and upper fixed point is the boiling point of water. Now, after we mark the 0 degree centigrade and the 100 degree centigrade in this case, which is the lower fixed point and the upper fixed point, we divide this interval into 100 parts each. So, we divide into 100 parts each, and each the the difference between one part is marked as 1 degree centigrade. So, this is how we construct a thermometer. We have a glass bulb extended into a stem through which there is a capillary tube, and we fill the bulb with mercury. When we heat the mercury in the bulb, the mercury level rises, and when you cool it, it falls. Now, we need to calibrate this one. So, to do that, we put the thermometer in ice that is melting, and the level at which mercury reaches, we will mark it as 0 degree centigrade, which is the lower fixed point. We then transfer the mercury into a container in which we expose this thermometer to steam, and the level to which the mercury rises, we will mark it as 100 degree centigrade, which is called upper fixed point. Once we have the upper and lower fixed point, we will divide the interval into 100 equal parts, and each part will be 1 degree centigrade. So, this is how we construct a thermometer. Now, as I said before, that there are different scales for measurements. So, these are the temperature scales. And I will represent this in a table. So, in the first case, I will mark the scale, then I will mark the lower fixed point, and then the upper fixed point, and the number of divisions that upper and lower fixed points is divided into. So, the first one, let us say the Celsius scale. The Celsius scale, the lower fixed point is marked as 0 degrees, upper fixed point is marked as 100 degrees, and the number of divisions that is divided into is 100. The next scale is the Fahrenheit scale, FAH Fahrenheit scale. The lower fixed point is marked as 32 degrees, the upper fixed point is marked as 212 degrees, and and it is divided into 180 equal divisions. The last scale that we have is the Kelvin scale. The lower fixed point is marked as 273, the upper fixed point is marked as 373, and the interval is divided into 100 equal parts. So, these are the 3 different temperature scales that we have. So, the Celsius scale, lower fixed point is 100, upper fixed point is lower fixed point is 0 degrees, upper fixed point is 100 degrees, and the interval is divided into 100 equal parts. In the Fahrenheit scale, the lower fixed point is 32 degrees, upper fixed point is 212 degrees, and interval is divided into 180 equal parts. The Kelvin scale, lower fixed point is 273, upper fixed point is 373, and it is divided into 100 equal parts. So, this is all for today. Thank you.